Hello, everybody. Good morning, good evening, and good afternoon. Welcome to Going Meta Season 3, Episode 11. And I hear some music. I don't know where the music is coming from.
Might be from my side, so that's a good sign. I was going to ask because I'm in a semi-public space for a change. So let me adjust my setup here. Apologies for that.
No problem. Welcome everybody to episode 11 of the third season of Going Meta. This will be the final episode of season 3. We'll take a short break and we'll be returning obviously with season 4 later this year. But it should be a fun episode. We want to take a look back at a couple of topics, a couple of themes. What happened previously in season 3, what's currently kind of our vibe, what seems to be top of mind. We can also take a look at now that it's published, the AI Engineers graph track, which is beaming with ontology topics. So I think that could be something we would take a look at. Obviously, the session is interactive. So as I said in chat already, if you like, if you have any questions for Jesus and Will, if anything is particularly on your mind and you would like to let us dive into that a little bit, then we should have some time towards the end. So please take it away in chat. And we had a question previously on 2 episodes ago, maybe, where somebody asked about the OKF, Google's Open Knowledge Graph format, where we were, not unprepared, obviously, but we didn't know how that looked like and what that looks in details. But Will recently spent a little bit of time with it and put on a little demo. So we'll look into that. So, dear viewer, if you watched this episode two episodes ago and asked the question, now is your answer. But everybody else, it should be interesting as well. But yeah, now I talked a lot, and obviously I'm super happy to have my 2 co-presenters here at the show, Jesus Barasa and Will Lyon. Welcome to Going Meta. Thank you for being here.
Good morning, everyone. Morning for me for a change. I'm more aligned with Will this week, so glad to be back after a bit of a pause. So looking forward to the conversation today.
Yeah, looking forward.
For sure, yeah, and I'm fresh back from vacation, so had some nice time off in the Pacific Northwest. While I was out there in the Seattle area, we joined the Graph Geeks group in Seattle for GraphCon 26. If you know Amy Hodler, she organized that group and that event, hosted at the Boundary offices in Seattle. So that was really cool. So a lot of that is fresh on my mind. So a lot of graph technologists kind of sharing what they're working on, what they're interested in, kind of how things fit into the AI space with graphs. So really interesting discussions from some folks at NVIDIA talking about what they're doing on training GNNs, folks from Google working on graph stuff across a few different projects at Google. Really interesting to see. I gave a talk about some of the skill distillation functionality in our agent memory service, which we also talked about on this show last time. So anyway, yeah, that's been my last week or so in the Pacific Northwest. It's been nice.
That sounds great. Although I have to say that the ultimate graph-ish, ontologies event was the one, I don't know if you heard about it, Will, but the one that Joshua Shinovier organized. It was a meetup by the beach in Santa Cruz. I've never done one of those. I mean, I would have loved. I mean, it's a shame I came here, just 3 days later. But I was really, really trying to make it. It must have been something special, right? It sounded brilliant.
That sounds brilliant. Yes.
I missed that one, unfortunately. Cool. Well, should we
Yes.
get to the discussion here? Maybe to start us off, we can take a look at the open knowledge format a bit. So like Alex said, this came up a couple of episodes ago. And we talked through this a little bit, just kind of what it is, and I mentioned that something we're monitoring and looking at it at Neo4j, trying some experiments, and we played around with this a little bit, so have something maybe a little more in depth to look at, and something for folks to play around with if you want to dig into this. So the OKF, the open knowledge format, this is a standard that Google has put out and is working to formalize this LLM wiki pattern. And so this is something that we've seen folks doing. Andrej Karpathy was talking about this, and in a tweet, lots of folks are having success kind of documenting in a like wiki style, right? Like lots of markdown formatted files with some front matter, some additional metadata, and an important piece is this idea of linking, cross-linking from markdown files to other concepts or elements, right? And that's like quite a graphy format. The idea is to then make this available. Think of this kind of like a bundle that can be kind of like a semantic layer across all the knowledge throughout your organization, and as well as the ability to go query it, right? And also important to note that like this is designed for both humans and agents to consume and write to, right? So we want some like curated format that agents are able to commit to. So I took a little look at this and did some experiments, and we kind of threw a demo and some slides together just to talk through this a bit. So first of all, we look like why does this exist? Like what's the point of having this knowledge format? And it's very similar to a lot of the things that we talk about with graphs at Neo4j, the value of combining data sets and querying across them, right? And so imagine where the organizational knowledge sits in your enterprise. It's across lots of different database and tables and policy documents, Slack threads, right? Like all these things sort of are isolated, and we'd love to be able for our agents to have access to all of this like disparate context, essentially, like throughout the organization. So this is essentially the gist of it, and kind of what I want to walk through in the next few minutes here is like, let's say we take this OKF bundle, and we'll dissect this in a bit to see what is actually in the OKF bundle, but think of it as a bunch of markdown files with some metadata attached, and we're going to show how we can like deterministically load that into the graph, and then we can use some of the graph rag concepts, including like text decipher, to be able to explore and query this data as it is materialized in the graph, right? So let's take a look at what is in one of these OKF bundles. This one, so let me drop a link to the repo if folks want to follow along. Let me find it here. This guy, yeah, this guy. So we'll drop this in the chat. This is just my private GitHub. I put this together. You can find the code for the ingester, with all the slides and things. But what I wanted to talk about is the actual example bundle. So I use this example. This comes from Google's knowledge projects, and there's a link to it somewhere where we grabbed that from.
I think yeah. Okay. Yeah.
Alex shared the link. Cool. Thanks for that. But anyway, yeah. So just an example bundle. So we didn't create that. We're going to skip over that piece of how you actually make one of these OKF bundles. But anyway, so that's the example we're using. And this describes like, hey, we have some data throughout the organization, and we have some data in BigQuery. Of course, we have some definitions of how we think about things like revenue and gross margin and how we calculate that for our business. We have a product catalog, right? Like all these sorts of things. And each one of these markdown files, like specifically the concept files, right? And the concept is actually the only like required part of the OKF metadata, is that we have a name for what the type of the concept is. So this is a metric. This is how we think about gross margin. And we have this metadata of like, okay, where did this come from? Who wrote it? How was it confirmed? What state in the life cycle is, sources. We have then the actual structure of the content here, and we can link, right? This is a markdown link. We're linking to like another concept document, right? This is a big piece of where the power of that like inherent graph is in there, right? So these references are obviously going to become relationships in the graph because they're where concepts depend on one another. I saw this just this morning. I think that this was a fairly recent update to the OKF specification. Was additional metadata in OKF to track things like data provenance, trust, this lifecycle thing that we just talked about, and how it was produced. So this is in the latest format, and so we're taking advantage of that here. And like as I pointed out, like this is inherently like a very graphy structure, right? We have concepts that are dependent, right? So our idea of gross margin, well, that's dependent on understanding like what is revenue. We have to be able to calculate revenue before we can calculate the margin on the revenue, and so on, and the policies that define that, right? Like these are all connected and inherently how those dependencies are expressed in in Markdown. That's a graph, and we can see there. I put together like a little visualization here that's in the repo just to kind of see what the data is. We have this example, just like the slide shows, right? We have this concept of gross margin. It depends on this idea of revenue. We have a legacy and outdated deprecated version here of gross margin, right? So like the dates are important here because policies change, these sorts of things. Then we have actual like instances of the data. Like we actually like ran this BigQuery query to actually like find what that revenue is, right? So anyway, just a little explorer to give us an idea of what kind of data we have in there. Why would we load this into a database though? And like, why isn't this just enough in Markdown? Well, like one thing that we're going to see is this idea of like the staleness, right? So we know that somewhere there's some like deprecated policy. If we do just like a vector search across all of this, that sort of like temporal component can be difficult to take into account. So we're going to see how the graph can help us find deprecated policies where staleness is kind of an issue. But then also we're going to be able to do these graphrag based retrievers as well, right? We're going to combine both vector and graph search to find like the most relevant information and take advantage of this like semantic layer across all of our data that's exposed through OKF. So this is the graph model that we're using here that aligns to the OKF standard. There's one thing that's not obvious here is like there's this type that we're inherently and explicitly stating for each concept in the OKF document, right? So like this one, for example, the type is metric. So then that would become an additional label. So we'd have concept, an additional label, metric to describe the type of the concept. Cool. And this describes kind of, how we can deterministically ingest these. We're not just going to pass a bunch of markdown to say, hey, build me a graph of this. We're going to actually, look at the structure of the markdown and apply some graph pattern to import that into Neo4j. Cool. So I don't need to go through all the slides here. They're in the repo that I linked. You can get kind of an idea of how this works. But let me jump to the demo, which is a Jupyter notebook here. And again, this is in the repo. Let me make this a bit bigger. And so what we're going to do here is I have this data locally. Again, I just checked out the repo. The only thing I did was added a OpenAI key to the .env file because we're going to use some text decipher at the end here to do some graphrag retriever pieces, but we're not using the model to construct. So first we're looking at, here's all these markdown files that we've got. This is our OKF bundle. We can parse the front matter, right? So the front matter in your markdown file is what's at the beginning, in between these ticks, and this is like the metadata, the type of the concept. This is where like the data provenance lives, that sort of thing. And then there's some code in here to apply that parsing of the markdown format and like deterministically apply these graph patterns to load this, and we can see we end up with 22 sections, 9 comments, 4 different sources, these sorts of things. Okay, so that's fine and interesting. We can start to query this. We can do things like how many of these are human reviewed versus unverified versus machine viewed. We can do things like look at the staleness of this data. Then we can start to look at impacts, right? So because we have the dependencies between some of these concepts, well, if the revenue recognition policy changes, we can traverse through these source nodes to find like what are the dependencies between these concepts, and we can start to see, the downstream implications of changing how we recognize revenue is going to impact, of course, our gross margin, and it's going to impact, of course, certainly how we've materialized our calculations of revenue over time, right? We can see both like the metrics, which are like concepts, but then actual like data, right? So we have an order table in BigQuery. This is going to be, related to how we're changing our understanding of recognizing revenue. We can visualize these as well. And so here we're showing that we're starting with the concept in our bundle here and finding all of the connections to this concept, whether that's the policies, other concepts that are dependencies, and just kind of returning that like that 2-hop graph there. And this points out like, hey, here's our legacy gross margin, right? It's still included in our corpus of data here. So we want to make sure that that is taken into account later on. Here we're looking for missing information, because you can, and this is common if folks are using like Obsidian or some of these markdown based note takers, you'll often like start a link to a new page concept that maybe doesn't exist yet. You've identified the thing, but you want to add some data to it later on. So we can traverse the graph to see, hey, where are we missing, sort of not implemented concepts yet, this sort of thing. Cool. Maybe I'll pause here, since we've now like constructed the graph from OKF, and we've seen kind of how that's modeled in the graph, some of the benefits. The next piece is I want to look at using the Neo4j GraphRag package to do some GraphRag retrievers on this, and this is where we're going to use our OpenAI key to do some interesting things with the LLM. But before we move on to that, maybe we'll take a pause here and see what folks think. I see some comments in the chat, but maybe Jesus, does this map to kind of your understanding of OKF and I don't know, other ways that we've seen out there of sort of defining this like semantic layer throughout the org?
Totally. Yeah, no, I think it's super interesting. I was gonna ask you, because you seem to have that on your is it on your personal GitHub repo? Are we linking it so people can check it out? It does totally, Will, to your question. So I think that's a great example.
Yeah, we have linked to the repo, but I can also link to the Jupyter notebook that you shared earlier.
Oh yeah, and the notebook is right here.
Yeah, I can share that. No problem.
Yeah, there's a kind of a comment more than a question. Can't read the user's name because it's just consonant. But
yeah, RWBTX.
There you go.
Yeah.
try to pronounce that.
Yeah.
But yeah, it's basically saying that OKF seems to be Google's attempt to implement the benefits of a graph without actually using a graph database like Neo4j. And well, his opinion is that it makes it brittle in his opinion. And I suppose there might be cases where an approach like this makes sense, right? Depending on volume but yeah, that's an alternative implementation, I guess.
What I don't understand,
certainly.
Yeah, sorry. What does it want to be? Does it want to be more of an ontology, or does it want to be a knowledge graph, model type thing? Is a bit. I don't know. Where does it sit?
I think of it as trying to bring a standard to the LLM wiki pattern of, hey, there's a lot of value in, constructing record of, you see this a lot. People start with this at like a personal level, right? As like, okay, as I go through my day, like let's keep, a well-structured sort of meta graph of okay, what are the work things that I accomplished today? If I'm researching some new area, let's keep track of the blogs that I read, the concepts from that, the papers that are useful, and how that relates to my work, like something like that, right? And at the organizational level, I think this is very similar to some of the things that we see folks building context graphs with, right? Is like, hey, I know that the policies, how those are implemented, the decisions that are made, those are very important. I want to have some like agent to allow my quickly and efficient content.
Is it just me, or are we losing Will?
I was going to ask you. I'm losing him as well. I was wondering if it was my network here, but it must be at his end.
Yeah.
So yeah,
it seems like we lost
necessary
to
understand
you're back
where
now.
this data lives.
Well, we lost you. Oh, is he gone? He's back.
Here we go.
Am I back? Sorry about that.
Back.
Lost you. The last kind of 30 seconds. Will, I think we lost you there.
Sorry about that. Yeah, I just saying, like, I think that what I see as big usefulness here is just having a format that allows you to quickly bring the value of this context to your agents, right? And allow your agents to construct this this LLM wiki style format going forward. And so having some basic metadata and standard attached to this allows you to use sort of like any format behind the scenes that's necessary, right? Like it doesn't need to be just like Markdown. The next phase of this integration that I'm going to play around with is, can we dynamically render an OKF bundle from an Neo4j database, right? If I have a maybe like an ontology based semantic layer, something like that already in Neo4j, let's generate this on the fly, similar to what we're doing with the skill distillation functionality, where we're generating the skill bundle dynamically on the fly from a Neo4j. Cool. Well, maybe let's jump back to the notebook here, and we'll see how we can use the graphreg package to do some retrieval on this. So if folks aren't familiar with Neo4j's graphreg package,
The thing is happening again.
It's a Python package that has
Yep.
Internet to that.
Yes, we're losing you.
Yeah.
Maybe I'll just go really quickly through the notebook then, and we can move on before I get lost completely. But the basic idea here that we're showing is how to use this concept
Of course, it was going to happen.
retrievers. And how we can use that to use not just Cypher to query the graph. Here we're using just a vector-based retriever. And the point that we're making here is with vector only, here we can see this legacy deprecated policy still rates quite highly in was this like cosine similarity score, I guess. But if we use a combined vector cipher traversal, well, then we can find that we're actually taking that information into account in the construction of the cipher query to leverage that deprecated information. Cool. So I'll stop there before my internet cuts out again. But the notebook is here. The text to cipher stuff I think is really interesting. This is like a really neat way to interact with your with Neo4j. This functionality, I should say, also is built into Aura Agent. So if you've used Aura Agent, which has this functionality built in, essentially, if you have your data in Neo4j and Aura, click a button and you get this like text to cipher retrieval. You can define the tools to interact with your database, similar through this, but it's in an environment where the agents are hosted and orchestrated in Aura, which is quite nice.
Cool. There was one more question from Ramona. Ramona asks, when you say skill bundle, do you refer to the skills.md file or something else? And if it is about preparing these MD files for agentic use, or is that part of the OKF, the one you showed in the beginning, like this setup?
Yeah, that's a great question. So I was referring to something that we haven't talked about today, but previously we talked about. Was this maybe the last episode? I can't remember. But we talked about in the Neo4j agent memory service. So this is a Neo4j Labs service that allows you to send agent messages, and this goes through like an entity extraction process to construct this knowledge graph of memory, both like short-term memory, which are the messages, long-term memory, which are it's essentially like the knowledge graph constructed out of those messages, and then reasoning memory, which is like the tool calls, the reasoning step of your agent, these sorts of things. So the Neo4j agent memory service sort of has all that functionality and exposes through like a HTTP API or MCP the ability to just wire your agent in and sort of get this memory functionality. And like what's interesting is the agent can like, sure, it can go retrieve the most recent memories, or let's say the most relevant memories rather, to get, you know, the most relevant information and put that in. That's, I don't know, that's like descriptive knowledge is maybe how I think of it. It's not like actionable knowledge, right? It doesn't tell the agent like what to do, which is where skills come in. So skills, this is the standard that Anthropic started and put out, and again, there are some similarities to OKF, right? In the format. One is like it's markdown with meta files with metadata. We've done some interesting research. Zach and the research folks published a paper on what happens if you model a skill as a graph. There's some actual benefits there with you if you break down the dependencies between steps in a skill. And then what we've done with this functionality in the Neo4j agent memory package is taken this concept of ape, like, hey, I'm modeling my skill as a graph, so I have the benefits there of understanding the dependencies between steps in the skill and this sort of thing. But I can also ground the skill in my method. I have the actual tool calls, the actual change over time. So let's say, for example, the memory system observes a tool call that fails or a tool call result the schema. We can flag that as stale, needs to be redistilled. This is kind of some similarities that I see, because here we're taking your agent memory graph, short-term, long-term reasoning memory, taking a successful interaction that you've had, a successful conversation with an agent, and you want to turn that into some actionable skill, and we're just like reading that from the graph that has been observed from a successful interaction with the agent. We're just reading that from the graph, but structuring that in the skill bundle, right? In some format that is then portable for your other agents. So that's where I see the similarity, is of, hey, we could just generate a OKF bundle dynamically from an existing Neo4j instance, similar to what we're doing here by generating the skills bundle from your memory graph.
Cool. On your comment,
hopefully my Wi-Fi stayed through for most of that.
It was good. It was good. Can you hear me now? Or is it?
Yes.
Good. No, I had a question, because you mentioned that the skill distillation was one way of making these kind of, well, in this case, reasoning traces actionable, right? In a way, and I wonder if because I suppose when you store memory, you can have, I mean, I guess you can, every time you get a new question or a new task by an agent, you can do a kind of a search for similarity. I mean, there's ways in which you can directly access raw, if you want, memory fragments, right? But I guess the distillation part gives it, makes it more robust, or you learn from a bunch of memory elements. But are there other ways in which you can kind of act on these memory?
Yeah, I think of it's kind of like the difference between, I don't know, like context stuffing and giving your agent a tool to that they can use, right? Giving them some new functionality, because typically when we're thinking of agent memory, it's something like this, right? Is you do some vector search and in the in the context, now the agent has to like address and like bind concepts to a bunch of text, right? Whereas with skills, you're giving the agent the ability to follow some structure of how to complete a task, almost giving it like almost a workflow, turning a non-deterministic interaction structured.
Yeah, makes sense. We lost you there for a second, but you're back now. Cool.
Yeah, cool. Thanks for that. There were 2 more comments here in chat from John. John says, it's interesting using graph to govern skills seems like a good idea. We'll need to research this. Yeah, I think could be interesting. Especially, I also shared the paper you mentioned. I think that's definitely something to look at from that point of view. And then Krish says you can check about using skills as nodes in a directed graph. And then he says this was developed as framework by NUS and Alibaba as skill graph. You might take a look at it. They are implementing this at their graph agents. Have any of you heard about the skill graph?
I want to say that is cited in Zach's paper. I've seen that term before, but I'm not super familiar with it. I'll have to go through the citations in the 8 paper and see if that's a reference. If not, we'll certainly give that a read. It sounds interesting.
Yeah, thank you for sharing, for sure. You wanted to say something, Jesus?
No, that was it. I was just following the questions on the chat. So all good.
Ramona has a more concrete question. Since we said we wanna take questions, I think we could take a detour. But I want to see if we have anything else to share on OKF and the topic before we open a new topic.
I think that's it from me on OKF, and there's a bit more in the repo. But hopefully you get the ideas, and again the slides are in here as well. So if you're interested, diving in, curious what folks think of this approach, if this makes sense, and kind of like I said, the next thing I want to try is generating an OKF bundle on the fly. So you already have constructed your graph in Neo4j. So that's kind of my plan to go from here.
Nice. Yeah, cool. I mean, it's always nice. So to see what's happening around in the scene, in the community, and especially when obviously somebody like Google adds something like this to the to the tech. It's nice to see what people are building, especially then now the like you said, the overlap and the integrations between different tools. I think it's interesting, and let us know if you build something with it, if you see this is getting more traction, if this is something people are doing. It's always nice. And if you have suggestions for other things you discovered, like let us know in the YouTube comments. It's probably the best place. If you have any suggestions, any comments, any questions you'd like us to address in some shape or form, we always like to hear from you.
Cool. Shall we move on to the second section of today's podcast?
Yes. Yeah.
So I understand that we're officially, Alex, confirm closing season 3. right?
Yes,
So
yeah, we are. We thought we do another extension here in summer in August, but September we'll take a break for sure, because I'm out. But also it's gonna be busy.
Perfect reason.
Exactly. We'll take a little breather. But we'll come back for sure with season 4, and Will also will stay with us in season 4. So we will extend the topics a little bit, and we will take a little bit of a broader look at the whole AI ontologies, and all things in between world. But today that's why we thought we take a little bit of time to look back into season 3. What did we cover? What were the topics? What's currently, like what I mentioned in the beginning, what's happening around the world of ontologies, which seems to be like an explosion not out of nowhere. We always followed it, but it was really interesting to see that this is now a topic that lots of people are talking about, lots of people are discussing, everybody seems to be having on their mind. And I guess you, Jesus in particular, probably are pleasantly surprised, maybe, but at least confident to see that we were on the right path all along.
Absolutely. We've been using it for years now, so it's great to see that they're getting wider adoption and becoming present everywhere, basically. So yeah, to your point, I think it's a sort of a tradition when we get to the end of a season to do a bit of not just a recap, but maybe if some of the people who are joining us have not joined the previous session, maybe we spend 10 minutes, 15 minutes going over the what we did on the chapters, the different chapters in this series, and then maybe use it as a way to maybe get some additional questions, or maybe to get people to have ideas on what do they want to hear more of, or what they find more interesting. So yeah. I think am I sharing? Because I was oops, is it that's not nice. Let me go on hang on, let me stop and go on full screen, because stop sharing, and I'm going to just.
You need to bring your travel monitor with you.
I know. I'm so not prepared. I mean, first the noise, and now that's. Anyway, let me give it a try. So I'm just going to bring the slides that we've used and run fast through them. So hopefully you can see it. If I go in slideshow, maybe you can see it better now.
Yep, here it is.
Is it good? Okay, so that was episode 1. So I'll go fast and not spend much time on each one of them. But yeah, this season has been a lot about ontologies. So ontologies has the artifacts, right? So not just how to use them, which is something that we've been for many years now, but we focus on how to create them, how to measure the quality, how to So this first one was one that we run with Alex Gilmore back then, and we used the data modeling MCP server that Neil had published shortly before, and basically what this MCP server did is take 3 inputs. So it takes some sample data. So it basically builds a model, a graph model, but we kind of tweaked it to take that graph model and serialize it and output it as an ontology, right? And we produce some OWL serialized as turtle. But basically the 3 inputs that it takes is some sample data, some we call it use cases, which is basically a collection of competency questions, and then some potentially reusable set of example models, like pre-existing ontologies, if we think of it. So in these 3 elements, it went into this kind of loop where it start producing models, and then you can interact with it and you can visualize it. I think it produced a mermaid visualization of it, and until you get to a point where you're comfortable with it, and it would generate, in this case, Cypher. But in our session, we saw how it could generate actually an ontology, and we run it with one of our favorite use cases, with the blue plaques in London that we've used many times. So that was the first episode. Then what we did in the second one is we had a look at Aura agents. That was in its early days, because this is roughly a year ago. And we looked at how to use an ontology to define tools. In Aura, in Aura agents, you can define, if I remember correctly, 3 types of tools, right? You can create vector search, you can do, I think it's text to cipher, I believe, and then parameterized queries. So we did, instead of hard coding them, and now I know there are APIs to access it, but back then we had to do it all through the UI. And what we did is create an ontology that would drive the behavior. So it was kind of a generic set of tools that would, rather than encode, let's say, declaratively, so not declaratively, the opposite, like procedurally, like what they were supposed to do. What they did is kind of, in a generic way, they would go check an ontology, and depending on what they found in the ontology, that would drive their behavior. So we kind of added this additional level of indirection. We went meta a little bit, and it was by changing the ontology that were driving the behavior of the Aura agent. And that was, we did a bit of an introduction, how to build a knowledge graph with another of our favorite data set, that the what was it, the Tate Modern catalog, and then we create a bunch of tools in the Aura agents experience. So that was the second one. On the third one, that was another of those interesting ones where we went through some posts that had been published recently, and about some of these usual misconceptions around how to use ontologies in the context of knowledge graph generation. And we looked at how, yes, you can use an ontology as a target schema when you're doing entity extraction. And the context was, there was a text document, an unstructured document, natural language, and we wanted to create a knowledge graph out of it. And the original article was claiming, hey, if you use an ontology describing OWL, you're going to get perfect quality graph. It's going to be perfectly aligned with the ontology. You're going to eliminate all sorts of hallucinations. And we went in a lot of detail explaining how, well, that's not entirely true, right? Because of course, the ontology, once you pass it to the LLM, is just text. I mean, the LLM, you can't think of it as an inferencing engine that would deterministically operate by applying rules. And what the LLM does is it takes the ontology as some kind of guidance, and yes, depending on the quality of the LLM, and we did a pretty exhaustive analysis on depending on the version of the LLM, you get different levels of quality. But one interesting thing, if you remember, Alex, was that actually we experimented with, okay, what if we pass the ontology, but instead of passing it serialized as OWL, a turtle or whatever, what if we kind of transform it into some kind of pseudo-natural language description of the ontology? Yes. And instead of saying something like class animal, we would say there is a type of entities which is animal, and it has these kind of properties. And it was basically a human readable, I mean, it was a text. And interestingly, the LLM performed as good as when you pass the ontology, if not better. And in some examples, in some cases, it was pretty indistinguishable, which kind of proved that, which was obvious, right? What we're saying, that once you pass the context to the LLM, the fact that it's structured doesn't make a massive difference. What it does, though, is when you produce structured output, you can validate that by using things like Pydantic, which is something that we use in the past. So if what you want to do is make sure that the output is structured output and aligns with a particular schema, well, you can force that, and that's one way of guaranteeing it. But anyway, so there were a bunch of those kind of misconceptions that we went through, and I think that was a pretty interesting one. Even the fact that it could still produce hallucinations. Of course it can. I mean, there's no guarantee that the LLM is still an LLM, right? So when it does the extraction, it can produce invalid output, and well, that's what we covered in that episode. I think it was a pretty fun one, and well, that's slides. Oh, we used a lot in this one. Anyway, going quick over them. Now, I was mentioning before about we looked at the ontologies artifacts, and in episode 4 we evaluated the quality of ontologies. We didn't come up with these rules, so we actually researched the literature over the last few years in papers where a number of metrics to evaluate the quality of ontologies had been documented anyway, and we identified 4 categories of metrics. Some were structural, like things like Are you creating orphan classes in your ontology? Are you creating highly connected classes in your ontology, or relationships that have certain structural characteristics? So you could define metrics based on the structure in the graph, because an ontology is a graph, right? You can also define metrics around how well the ontology aligns with your requirements. And the proxy to our requirements was this collection of competency questions. And we evaluated that using LLMs, obviously. So how does the ontology that you've created, how is it able to answer the questions that you provided as input, right? So, and that would give you, again, a score indicating how much it matches the requirements. The third category was around sort of pragmatic metrics, like things like, is it well documented? I mean, when you define a class, you provide a rich natural language description of it, et cetera, et cetera. You're using good terms and things like that. So that's another category. And finally, the one that's more sort of advanced is if you use strong or more sophisticated logical constructs in your ontology, like axioms and things like that, make sure that you don't introduce anything that's logically inconsistent. And for that, we used obviously reasoners, because the only way to do that is by applying formal inferencing. So we showed how these metrics could be transformed into a collection of cipher rules in this case, and we created a dashboard which is in the GitHub repository of the series. So it's all there, and I think that was pretty interesting, because then we used that to come back. Well, before I get into that, we did a brief introduction, Will, and I think I mentioned that to you before you joined us, to the agent memory when it was released, and it was a pretty basic one. I think it was a month that you were not around, Alex, and Adam Cowley did the webcast with me. So yeah, we went over your articles, Will, and we went through the repository and explained the three types of memory: short-term, long-term, and reasoning. And we did some basic examples, I think, of the two first types. So that was a very introductory one, but I think it was quite interesting. And then we came back to another topic that we've talked about quite a few times, actually. And I believe, interestingly, Will, the first time we talked about Shackle, it must have been like 4 years ago, and you were doing the Going Meta back then. But anyway, Shackle, as most of you know, is a vocabulary that makes it possible to define constraints on your graph, and constraints of different types, like structural constraints, like cardinality. You can define constraints on values and properties. So it's a pretty rich language to define what you expect the shape of your graph to be. And many years ago, we created that implementation of Shackle first in Semantics. Then we implemented a separate one as a Python external client-side component. And we went through it in this, actually I make reference to this, it was in 22 where we talked about it first, then again in 23. And basically we showed how taking these constraints defined in Shackle could be used to generate validations implemented as Cypher, and produce reports that would effectively detect any kind of violation of the constraints defined in Shackle. So that was this episode, and it was here where we came back to the ontology creation. This time we used skills, and I believe we brought in here this idea. I mean, it's kind of a refried version of what we had shown with the MCP, with the tools approach. So we created a rich skill that would basically implement the same methodology. It would take competency questions and the description of the requirements. It would take some sample data, and it would take any pre-existing ontologies. And again, it would iterate. It would generate a visualization based on Mermaid or something like that. It would allow you to provide input, to comment, to critique what's been produced, and iterate until you get to a point. What we introduced, and that was interesting here, is we at each iteration we would run the collection of metrics to make sure that the quality of the ontology according to those metrics did not degrade as you iterated. So that was the interesting bit about it. And again, the skills are in the repo, so nothing special about it. And then we enrich that using in episode 8 using the procedural memory. So what I thought is that it would be a pretty cool use case for it, because if you think of it, what the agent in charge of creating the model does is making a series of decisions, right? So I was thinking, every time the agent makes a decision, well, let's trace it as procedural memory, right? And we use the memory package. And what was great, I can't remember if we showed it at this episode or it was later on at some other event, but what's interesting of persisting it as a trace, as procedural memory, is that ontologies by definition will evolve over time. So you may run your first version of your ontology in a session in I think we did that in I don't know if it was Cloud Desktop or whatever. You produce the ontology, you probably put it on your GitHub repository, and you have your trace persisted in Neo4j. And probably maybe months later, the ontology evolves, but this time you're using cursor for it, right? And you can use the same skill, of course, and you can get back to the memory, to the traces, to make sure that you don't undo some of the decisions that were made back then. So it was a great way of capturing the traces and then using them as additional inputs to iterate over the ontology. So that's what we meant by the graph, behind the graph. So it was a construction of the ontology. We persisted it as procedural memory. So that was it. And then here is where we were lucky to have Will join us, and then we started adding additional topics around memory distillation, etc., etc. So that's what we've done this season. I don't know if you're nearly out of time, but hope that gives a bit of an overview. And yeah, like I said before, maybe give people ideas of what we can do more of, or just pointers to get back to these episodes and grab the assets and play around with them on your side.
Super, yeah.
It's really impressive to look through like all of these topics and see what's been covered, right? And I think it's interesting. I mean, you have basically like a master class that's been assembled over time. But like, what's really interesting that stands out to me that is really cool is the things that we're covering and how we're covering them are evolving, especially like as a lot of these AI workflows and new AI tools. And I mean, we were talking about like how OKF, fits into all of this too, which is itself brand new. So that's the thing that stands out to me as you were going through all of this, is like, this is really like interesting, cool learning stuff to see how it's applied. But it's also like, it's the new things that folks are trying to figure out, like, okay, here's some new AI thing. How is this relevant given our understanding in the field and best practices that we've done so far? How does this fit in? Let's dive into it, which I really like that format. So yeah, so kudos.
Absolutely.
That's cool.
We like you said, Jesus, we are also almost out of time. So I'm not sure if we have room for Michael's question on whether ontologies are only being considered one if inference can occur without explicit data. So meaning RDF schema can infer information given a certain amount of data, whereas property graphs must be made explicit. And if we have overcome this hurdle,
well,
can we give a quick answer?
Sure. I mean, yeah. I mean, we this is something that we've touched on many times. I mean, there's two things. We see. I mean, I see the ontology as I think of the ontology as the configuration file for the reasoning, but the reasoning is a kind of a separate component, right? So you have data, right? Whether it lives in a property graph, in a triple store, or whatever, and you have an ontology that describes that data, or that gives you some information about that data, which entities are there, what relationships are there, what are the characteristics of these relationships. Some of them are transitive, some of them are sub-properties of others, etc., etc. So you give a rich description that's actionable. And then you have another component, which is an inferencing engine. And the inferencing engine will read the ontology, that's why I refer to it as the configuration. The ontology itself does nothing, right? So it's descriptive, it's a passive element. It's the inferencing engine that will read the ontology and then do something on your data. And one thing that can be done is, derive new data. Hey, you told me that the relationship dependency depends on is transitive. So if A depends on B and B depends on C, I can derive that A depends on C, right? It's a simple, that's a simple example, but that's the idea. So with my description, you see that these three are separate components. And we've been using a lot, of course, data in Neo4j forever. We've been using ontologies, often defined in OWL, why not? And then, maybe there is not a general purpose inferencing engine that operates on, I think there was, some companies have worked on that over the years, but yes, we've built certain types of inferencers or tools that do something. Shackle was an example, right? So Shackle is another variation of that. So we have a Shackle engine that takes a Shackle description, runs on graph data, and returns a report on the violation. So it's exactly the same pattern. So it's an active element, which is the Shackle engine that operates on the Shackle definition. So to Michael's question, I don't think there's really a hurdle. I mean, in the sense that, yes, that can be done. I mean, I don't see, and maybe the fact that no one has created an inferencing engine for maybe property graph data is because there's no such demand. But I think there's still the value and the relevance of having a declarative description of the ontology on top of graph data in a property graph. I mean, what do you do with that? It's entirely up to you. And we've given you many examples over the years here. But I think it's that's the answer that I would give. Hope that sort of makes sense.
Yeah, cool. Thank you, Jesus. On the point of how to get notified when new episodes come up, there is not a dedicated Going Meta event stream yet. Maybe in the future. But at the moment, no. The best place I would still think is YouTube. So if you subscribe to our channel and hit the little bell icon, then that gives you a notification whenever something pops up at the Neo4j account on YouTube. And then obviously Going Meta will be one of those sessions, and then you would get notified. You could also check out our events page and subscribe to that. That also gives you updates whenever something comes up, but it's not specifically to Going Meta. It's going to be every event that we are hosting. So it might be a little bit much. Yeah, I think that rounds us out for today's event. I'd like to invite you all on the 11th of August next week. I have two guests who talk about graph agents with multimodal entities and reasoning schemas. And even if the abbreviation gamers was used, it has nothing to do with games. It's a health and life sciences topic, patient data and patient journey data in made available for graph agents. So Julia and Krishnendu will talk about this next week. And I think that's it. Oops, wrong slide. Here we go. If you are interested to know more about Neo4j, Graph Academy is a good place to learn. Or free is forever there for you to play and have fun with Neo4j, and our community pages give you all the information. Lots of interesting data and tutorials, workshops, and more to read about. So yeah, I think that's it for this episode. Thank you, Jesus and Will, for joining me today and for presenting on very interesting topics. As always, like we said, we'll take a little break in September and we'll be back later, either October or November, but definitely season 4 will continue with Going Meta. So I'm looking forward to that. And until then, have a nice summer, everybody. Have a nice time, and see you maybe next Tuesday already for the next show.
Excellent. Bye, everyone.
Thanks.
Take care.
Bye-bye.
Bye.